I want to welcome you to lecture 8. This is part 1 of this is a graph of a function. So this is for college algebra. My name is Jorge Young, and so there are two objectives. The first thing is we're going to identify the graph of a function, and then we're going to obtain information from or about the graph of a function. So the first thing is we're going to talk about the vertical line test. And the vertical line test essentially is a set of points in the x and y plane. It's the graph of a function if and only if every vertical line intersects the graph in at most one point. And I talked about this in class a couple of weeks ago. So here we can see that we have the graph of two equations or two functions. So we're going to determine whether they're functions. So the first one is y equals x squared, and the next one is y equals x to the third power. And as you can see that in A, there's a vertical line, there's two vertical lines, and they intersect the graph at only one point. So it doesn't intersect the graph at 2 points simultaneously. So therefore, A is a function, and then B, you can see that also is a function. So here are two examples of the graphs of equations that are not functions. And for C, we have x equals y squared. And you can see that the vertical line actually intersects the graph at 2 points simultaneously. In other words, there's a repetition of the x values. So when x is 1, there are two possibilities, x equals 1 or x equals -1. So therefore, that is not a function. And then D is a circle, x squared plus y squared equals 1. And you can see the vertical line test intersects it at 2 points simultaneously. So neither one of these is a function. So the next thing is we're going to go ahead and get some information from the graph of a function. So we're going to find what f of 0 is, what f of 3 pi over 2, and what f of 3 pi is. So f of 0 equals 4. And you can see that on the graph. So when x is 0, we get 4 for the value of the function. F of 3 pi over 2 equals 0. Again, you can see that on the graph. F of 3 pi equals -4. And again, we can pick that out from the graph. We don't have to do any computations to figure that out. And then, so what's the domain of the function? The domain of the function are for which values of x is this function defined. And so this function is only defined when x is between 0 and 4 pi inclusive. So it includes 0 and it includes 4 pi. So what's the range of this function? So we're looking for what are all the possible values of f of x given the domain that we have. And what we get is that the range for this particular function lies between -4 and 4, inclusive. So we're going to go ahead and list the intercepts. So the first one is 0, 4. The second one is pi over 2, 0. And then 3 pi over 2, 0. And then 5 pi over 2, 0, and 7 pi over 2, 0. So the intercepts are when the graph crosses the y-axis and when it crosses the x-axis. Now, how often does the line y equals 2 intersect the graph? So here's the graph of the line y equals 2, and we can see that it intersects the graph 4 times. So for what values of x does f of x equals -4? Now, looking at the graph, we can see that there are two values, and those two values are pi and 3 pi. And then, so the last thing is, for what values of x is f of x greater than 0? And so we can see the 0 line, which is the x-axis line. So the values for which values of x is this function greater than 0? And so we can see that they actually greater than 0 between 0 and pi over 2. And you can see that it's above the x-axis, 3 pi over 2 and 5 pi over 2. So here's the 3 pi over 2 and 5 pi over 2, and all of that lies above the x-axis. It does not include pi over 2, does not include 3 pi over 2, does not include 5 pi over 2. And then the last one is 7 pi over 2 to 4 pi. And 7 pi over 2 is not included because they equal 0 at these 4 points. So here we have a function. So it's f of x equals x over x plus 1. So is the point 1 and 1/2 on the graph? So what we do is we evaluate the function for the value of x, which is 1, and we get 1/2. So therefore, it is in fact on the graph of the function. So if x equals 2, what is f of x? And what is the point on the graph? So what we do is we evaluate f of 2 and we get 2/3. So the point on the graph is 2 and 2/3. So x is 2 and f of x is equal to 2/3. So if f of x equals 2, what is x? And what's the point on the graph? So what we do is we set the function equal to 2, and then we're going to solve for x. So we multiply both sides by x plus 1, and then we slowly solve for x, and we get that x equals -2. So the point on the graph would be -2, 2. So the last thing I want to talk about is average cost function. And so the average cost function is a way for manufacturers to find out what is the average cost of producing the next widget, if you will. So here we have where x is the number of computers per day, and the function, the average cost function, is given right there. So we're going to determine the average cost of manufacturing 30 computers, 40 computers, 50 computers, and then we're going to graph the function of C bar. And so where this particular function is only defined between 0 and 80. So in other words, they can only manufacture between 0 or 80 computers a day. That's their limitations. And then we're going to find the value of x that minimizes the average cost. So 30 computers a day would be $1,351. 40 computers would be $1,232, and then 50 computers would be $1,293. So here we can see that from 30 computers to 40 computers, the average cost per computer is actually decreasing. And then from 40 to 50 is actually increasing. So what happens is then that our the value that minimizes is going to be between 40 computers and 50 computers. And we're going to do it by looking at the graph of this particular function, and we find out that the cost that the amount of computers that actually minimizes the average cost is 41 computers per day. So at 41 computers per day, you minimize the cost per computer that you produce, so that would be the optimal number of computers to produce. And here's the graph for that particular function. And if we have zoom capabilities, we can actually zoom in when x equals 41 and find out that that is in fact the lowest value for this particular function. So here the value is decreasing, and then it reaches 41, reaches a minimal amount, and then and then it actually starts increasing again. So to summarize, graph of a function is just a collection of points x, y that satisfy the equation y equals f of x. Vertical line test is just a method to find out if the graph is that of a function. If the vertical line intersects the graph of that particular equation or function at just one point at any given time, then it is a function. If it doesn't, then it's not a function. And that's the end of lecture 8, part 1. Thank you.